the game back. Yes, that's the idea. But a lot of games are not simultaneous, not sequential, but simultaneous. In other words, when I'm choosing my action, I have no idea what you have done. Right? And when you are choosing the action, the history is not observable to you. And that's what a simultaneous move game is. So there are no trees, right, in simultaneous move games, because we don't even know where to start, because there is no starting point, right? We both move at the same time. Is that okay? It's like playing rock, paper, scissors, right? Rock, paper, scissors is not sequential, because if it was sequential, it would be the stupidest game. So the idea of the rock, paper, scissors is you have to have it simultaneously, right? Otherwise the point of the game is going to be lost. So that was the simultaneous. So that's the next set of theory, for example. Most of us, of course, have heard of. So the way we represent this simultaneous move games is through matrices. So the most famous. Let me give you two famous games. This is the most famous game of all. I'll just talk about it briefly, because all of us have heard of it, I'm sure, at some point in time. And then there is this game called the game of chickens. So let's just first talk about the prisoner's dilemma of the game. So this is so very common. I don't know whether you guys are crime show fans, but I used to watch a lot of Law and Order when we were growing up. Law and Order episodes have been running forever. But anyway, so most of this, I mean, 50% of the Law and Order episodes is that there are two guys who've committed a crime. They're taken to two different rooms. Cops in the room one is telling the guys that, you know, the room two guy is just blabbering and telling everything bad about you. Saying that you are the guy who did it. And then they go to room number two and say, room number one guy is just an absolute idiot. And this is how they try to break them down. That's a perfectly legal strategy, right? Cops can lie to prisoners. And it works almost always. And the reason it almost always works is because of this game called Prisoner's Dilemma. And I'll show you exactly what it means. So let's say you and I have committed a crime together. So let's say we both have robbed a bank. And now we've both got arrested. The cops have some sort of a traffic ticket on us or something, but they can't really prove that we have robbed a bank together. So I have two options. I can either cooperate with you. In other words, I would not tell the cops that we robbed a bank. That, we'll say that we were, shooting pool or something. Or I can defect. And I can tell the cops that, yes, we robbed the bank, but that guy was the main man. He was the planner. I was just an innocent bystander. So I've got two choices, right? Either I cooperate with you, not with the cops. Remember, cooperation doesn't mean with the cops here. So cooperate or defect. So cooperating with you means that I'm not going to tell the cops anything. And defecting means I'm ratting you out. You've got two choices too, sitting at your jail cell. You've got cooperate and you've got defect. Is that okay? And I have to choose my strategy not knowing what you have done. And you have to choose your strategy not knowing what I have done. So let's say we both cooperate. Then we both go to jail for a year. We have some outstanding parking tickets or something. So none of us say anything bad about each other, but we go to jail for some sort of unrelated charge. Yes. If we both defect, that means I'm saying that you are the culprit and you are saying that I'm the culprit. So the cops have too much evidence in some way, right? So we both go to jail for, let's say, 3 years each. Yes. And if I cooperate, that means I'm not ratting you out, right? And you defect, that means you are saying that I'm the guy who did it. Then you go free and I go to jail for 7 years. Is that okay? Is that true? And similarly the other way around. So the question is, when we're sitting at home, sitting in our own jail cell and thinking about what to do, the question is, what should we do? So here comes the problem, right? Now we have to decide on what to do depending on what I think you're going to do, right? And what you're going to do depends on what you think I'm going to do, and so on and so on. So we have to have a lot of coffee and decide what we should do. Yes? So let's say you are sitting in your jail cell and you're thinking about what to do with me. So you're thinking, okay, let's say Professor Banerjee decides to cooperate. decides to not rat me out. We have robbed the bank, but he decided not to rat. So what should I do? If I cooperate with him, then I will jail for a year, right? If I defect, I can go home tomorrow. So if you cooperate, my strategy is to defect. Is that okay? Yes. If you defect, if I defected, if I said bad things about you, now you've got two choices. If you cooperate, you're going to jail for 7 years. And if you defect, you're going to jail for 3 years. Is that okay? So you're going to defect. Is that clear? So regardless of whether I cooperate or whether I defect, you're going to defect. But that's the best thing you can do. Is that okay? Is that clear? So you're thinking, and similar, I'm as smart as you are, hopefully. Right? So since you have decided to defect always, I'm thinking the same thing. So I'm going to defect also, right? So both of us will rat each other out, and that's exactly what happens. And we both go to jail for 3 years. Is that clear? However, so we are too smart for our own good. You see what I'm saying? Because if you're both dumb, then there's this beautiful payoff waiting for us, right? Yes? So, but we think we are smart, and we are equally smart, so we both go to jail for a longer time. So suppose I call you up in the middle of the night, suppose somebody slips up with a cell phone, and I call you up in the middle of the night and say, listen, I have drawn this game, matrix game in my jail cell. So we both know that we are going to defect tomorrow, right? And we will go to jail for 3 years. Why don't we decide, why don't we just cooperate and go to jail for a year? Let's do that. Why don't you cooperate? And my jail partner would say, sure thing, why don't you cooperate? Because the moment I decide to cooperate, he'll just defect and get nothing. Right? He'll go to it. Is that okay? So regardless of how much we talk to one another, we both defect. Is that okay? So that's the prisoner's dilemma. So this is what is called, so this solution is what is called a Nash equilibrium, where we are both doing the best given what the other guy is doing. Is that okay? And what the point is that in the Nash equilibrium might not be optimum for both parties. So let's take one more example. So let's take the game of chicken. So think about a scenario, let's say it's a Friday night and people are drinking a lot. Let's say freshmen, just to make it, I hope there's no freshmen here. So, and then both people get in their respective cars, 2 people are drinking, they get in their respective cars and they go on the same lane. One of them drives towards the other drives towards each other. They're playing this game of macho chicken. So the idea is that I'm going to stay on my lane longer than you. So I'm going to stay and gun my car, you're going to gun your car, whoever swerves loses. Is that clear? So think about the game in the following sense again. So I have 2 strategies. I can stay, that means I'm going to stick to my road wherever I am. Or I can swerve. Yes? I can stick to it or I can swerve. Yes. You have the same strategy. You can either stay or you can swerve. Is that okay? The question is, so let's say, what are the payoffs? Suppose we both stay. That means I decided to stay and you decide to stay, then we just hit each other and we both die. And let's say dying is -10. So you both sort of run into each other and we die. So let's say I stay and you have swerved. That means I won macho points and you are, you have lost. So then let's say I get 5, yes, and you get nothing. Is that clear? So winning is 5, losing is nothing. Similar 0-5. Symmetric, right? 0-5. And let's say swerve, that means none of us have won. We both have lost. But at least we're alive. This is a good thing, right? So it's a draw, but we're alive. Yes? So that's the payoff. Are you guys all with me here? Okay. So now the question is, what is the equilibrium in this game? In other words, what are the strategies one should choose so that none of us would regret a choice given what the other guy has done? Is that clear? That's what a Nash equilibrium is that I suggest a pair of strategies such that I don't regret my choice given what you have done, and you don't regret your choice given what I have done. Yes? Once we observe what each other has done. Of course, in this case, regret means probably death or something. But I mean, you understand this one, right? So let's take this strategy. Stay, stay. I stay, you stay. Is that a Nash equilibrium? Can that be an equilibrium? If you decide, am I doing the best given what you are doing? And the answer is no. Given that you are staying, I should not stay. So we are not doing the best given each other. So this is not an equilibrium. Is that clear? Is this an equilibrium? Swerve, swerve. Is that an equilibrium? The answer is no, right? Given that you are swerving, I'm not doing the best by swerving. I should stay. Right? Is that okay? How about I stay and you swerve? Is that an equilibrium? Let's say I stay and you swerve. Is that so? Am I doing the best given what you are doing? You are swerving. So am I doing the best by staying? The answer is yes, right? Given that I'm staying, are you doing the best by swerving?
Yes.
Yes. So stay, swerve is an equilibrium. Is that okay? So this is an equilibrium, and so is this. We don't know which one of them would be chosen. That's the life and death problem here, right? But the problem is there are two equilibrium here where one person stays and the other person swerves. Is that okay? And that's what a natural equilibrium is. So whenever I look at this game, of course it's a weird game to talk about. But so if I was playing this game, for example, with you, and this is the only game we are playing all our lives, what I would have done is, let me suggest what I would have done. I would have yanked my steering wheel out of my car, put it outside my window, wave it, and then throw it outside the window. Is that true? So I'll take the steering wheel out of my car, wave it over my head, and throw it out the window so that you can see that I've done it. Why? Because once I do that, then what happens? That means I don't have this option anymore. Is that okay? So what I'm showing you by throwing the thing out of my window is that, even if I'm chickening out in the end, I have no choice. I have to stay. Yes. And then you're a rational person. Given that I don't have this strategy, what should you do? You know that I'm going to stay. I have another option, right? So you have to swerve. Is that okay? So I can guarantee this outcome by yanking my steering wheel. Is that okay? So this is the idea, but of course this is a tongue-in-cheek example, but the idea is, if you are, one of the ways, let's go back to the Greek days, and there's this famous article by Xerxes about military strategy, is that when you're attacking, suppose some other army, what Xerxes suggested is that you burn the bridges behind you. Yes? So that you cannot retreat even if you want to. Do you see? So the other side would think that these guys are completely insane, so let me retreat. That was his suggestion for a strategy. Is that okay? So this same concept can be used in military strategies, for example, where let's say the Russians and Americans have nuclear bombs pointed at one another, and a nuclear bomb accidentally goes from Washington and hits Moscow. While the nuclear bomb is actually going from Washington to Moscow, the American president calls up the Russian president and said, listen, there has been a tremendous mistake. We just found that the nuclear missile is going towards Moscow. That was a mistake. Let bygones be bygones. And at this stage, the optimal thing for the Russian government to do is to say, yes, if I